acidic property of ethine or alkyne one. Let's see compound ethine. This is ethine or acetylene. In this lesson, we are going to learn how this compound acts as acid. The compound is mildly acidic in nature. But how? Let's see the detail. This is ethine or acetylene. Another hydrocarbon is this, which is ethene or ethylene. Another compound, this one, which is ethane. Here, these three compounds are hydrocarbons. This is unsaturated hydrocarbon, this is unsaturated hydrocarbon, and last one is saturated hydrocarbon. From these hydrocarbons, this compound shows acidic nature, but these compounds cannot show acidity. But how? Let's see the matter through orbital structure of carbon-hydrogen bonds. Though hybridization and orbital structure have been discussed in detail in the previous lesson, nevertheless, let's see again. Here, carbon-hydrogen bonds. These carbon atoms are sp3 hybridized. Here, this is the carbon. This is sp3 hybrid orbital, which is bigger in size, because here 1s and 3p orbitals participate in hybridization. That is why this hybrid orbital is bigger in size. This hybrid orbital, sp3 hybrid orbital, overlaps with s orbital of hydrogen to form carbon-hydrogen bond. This carbon-hydrogen bond. In this case, carbon atoms are sp2 hybridized. Suppose this is carbon atom, this is sp2 hybrid orbital, which is smaller in size than sp3 hybrid orbital, because here 3 orbitals participate in hybridization, s and 2p orbitals, sp2. This sp2 orbital overlaps with s orbital of hydrogen to form carbon-hydrogen bond. In this orbital, s character is 33.33%, but in this case, s orbital is 25%. That is, percentage of s character increases, and in this case, carbon atoms are sp hybridized. Suppose this is carbon atom, sp hybridized orbital is more smaller than sp2 and sp3 hybrid orbitals, because here only 2 orbitals participate in hybridization. In this case, s character is 50%. That is why sp hybrid orbital is smaller than sp2 and sp3 hybrid orbitals. This sp hybrid orbital overlaps with s orbital of hydrogen. Here, covalently bonded electrons, electron cloud between carbon and hydrogen. Here, covalently bonded electrons. Now let's see distance between carbon nucleus and covalently bonded electrons in these carbon-hydrogen bonds. Here, suppose this is carbon nucleus, here electron cloud. Distance is this, but in this case, this is carbon nucleus, electron cloud. distance is shorter than this one, because here hybrid orbital is smaller in size. In this case, this is carbon nucleus electron cloud. In case of ethane or acetylene, distance is smaller than ethene and than ethane. So, in case of ethane or acetylene, electron cloud is attracted by carbon nucleus with additional force, because here distance is smaller and this carbon, sp hybridized carbon, electronegativity of this carbon is 2.93. In this case, the distance is a bit higher than ethane. So, electron cloud is attracted by carbon nucleus, but not like ethane. Here, electronegativity of carbon is 2.73. That is, electronegativity decreases. And in case of ethane, hybrid orbital is bigger in size. That is why the distance is higher than ethene and ethane. That is why electron cloud is attracted with less force. Here, electronegativity of this carbon, sp3 hybridized carbon, is 2.53. That is, simply we can say that electronegativity in acetylene carbon is higher than ethylene carbon, and after that ethane carbon, and as a result this electron cloud is attracted towards this nucleus, carbon nucleus of ethane, with additional force, because its electronegativity is higher. That is why this hydrogen gets freed as proton comparatively easily. But in this case, distance is higher, electronegativity is lower. That is why this hydrogen doesn't get freed as proton. No proton is produced from ethene. And in case of ethane, the distance is highest. That is why there is no scope to produce proton from ethane, as ethane and ethene cannot produce proton. So these compounds are not acidic in nature. But ethane or acetylene can produce proton, so it can act as acid. Now let's see acidic reaction of ethane. Ethane or acetylene, when this compound is treated with sodium metal in liquid ammonia, that is, here liquid ammonia is used as solvent. Water is not used, because when water is used, then sodium will react with water to form sodium hydroxide and hydrogen. To prevent this reaction, liquid ammonia is used as solvent. Here, these hydrogen atoms, acidic hydrogen atoms, are replaced by sodium to form this compound, sodium plus. Here sodium plus, hydrogen is formed as byproduct. In case of ethane, electronegativity of carbon is higher than hydrogen, 2.97. That is why carbon hydrogen bond undergoes heterolytic fission and proton is produced. that converts to hydrogen gas ultimately, and sodium acetylide is formed. From this reaction, we can say that ethane acts as acid. Let's see another reaction. This compound, 1, 2, 3, 4, 5, pentyne 1, that is a kind of alkyne one. When it is treated with ammonia called cuprous chloride, then this hydrogen, which is linked up with triple bonded carbon atom, this hydrogen is acidic hydrogen, which is replaced by copper to form this compound. Its name is copper pentylide, and byproducts are ammonium chloride and ammonia gas. So here alkyne 1 acts as acid with ammonia called cuprous chloride solution. Another compound, butyne 1, a kind of alkyne one, reacts with ammonia called silver nitrate. Then this hydrogen is replaced by silver, acidic hydrogen, to form this compound. Silver butylide. Here byproducts are ammonium nitrate and ammonia gas. In this reaction as well, we see that alkyne 1 acts as acid with ammonia called silver nitrate. Another reaction is ethane reacts with ammonia called cuprous chloride. Then these two hydrogen atoms, acidic hydrogen atoms, are replaced by copper to form this compound. Here byproducts are ammonium chloride and ammonia gas. Its name is copper acetylide, which deposits as red precipitate. So in this reaction, we see that ethane acts as acid with ammonia called cuprous chloride. From these reactions, we can say that ethane and alkyne 1 can act as acid because of the presence of hydrogen that is linked up with triple bonded carbon atom. So ethane or alkyne 1 show acidic property. This is all about acidic property of ethane or alkyne 1. No more today. Thank you very much.